Hello, folks. Welcome to Rational Science. Why is it called rational? Well, because we do a little somewhat different things than other sites do. They move concepts around, and we think that's irrational. Here, we don't move concepts. We do not shake the field, or we do not move the mass. We do not wave the wave. We do not move, especially mathematical concepts. We move objects, and that's why it's a rational proposal. You can always visualize what we're talking about. We can make illustrations of everything that we say here. Something that the mathematical establishment, especially, and just about every dissident out there as well, they can't do that, because whatever they put is not a physical object. It's a concept. And that takes us to language, and no, that's not semantics. It's called physics. Rational physics. Okay, today we're going to be talking about whether math is equal to physics or physics equal to math, or if physics is something else. And there's a lot of opinions on that, but we're going to do more than just give an opinion. We're going to try to justify this. And before we get there, we're going to talk a little bit about some of the extinction, especially questions that came up. Last week, we talked a little bit about the Neanderthals, and we always more or less touch upon the subject of extinction one way or the other. There were some issues that were brought up, some comments, primarily comments, some questions maybe as well that people have in their minds. So let's address those as well. Let's start there. Let's start with the Neanderthals. A fellow asked the question or made the comment, says, there's no proof that the Neanderthal went extinct. Europeans are Neanderthals. Okay, so all Europeans are a bunch of Neanderthals. They did mix with African Homo sapiens. Okay, well, I don't know. Did they mix with Africans? I thought it was the other way around, that they, the official story is that they did not mix with Africans. That if anything, Africans got it from people, like me, white men who went into European territory, found the Neanderthals, allegedly interbred with them. Maybe they interbred with them in the Levant. And from there, they took the genes to sub-Saharan Africa. Okay, so the issue there is that they say that, especially people in southern Africa have very little Neanderthal blood. That's essentially the argument. They say the reason for that is they did not mate with the Neanderthals directly. Okay, different species make hybrids. All the time. So you can't define species based on the ability to reproduce together. Are donkey and horses the same species because mules exist? No difficult to explain at all. They are just projecting this extinction because the people that rule Europe want to genocide Europeans. Talk about wearing a tin cap. Yeah, no, what can I say? You got to do a little more research on Neanderthals before you can talk about them. You got to read more papers to get a feel for who the Neanderthals were, and etc. Before you can even come into the discussion. Now, there's something right there at the bottom that I like to point out, because I'm saying not only were they two different species, and no, two different species do not really produce, even if they are able to mate, if they're close species like lions and tigers, or like he said here, horses and donkeys, even if they reproduce, and they produce, like in this case, the mules or the tigons or the ligers, the problem there is that the offspring are sterile. So or they have some kind of problems, genetic problems, that doesn't allow that new species, you could say, to prosper. Okay, so no, even though close species can mate and produce offspring, doesn't mean the offspring, will be viable or that they will continue the species. Okay, So that's the first problem. The other problem is there you see the Neanderthals. That's an example only, but it's that takes it right to where the point is. You can see that skull is totally different than the skull of a human. So if we were to dress it up, we would end up with some kind of ape that does not resemble humans. Okay, it's got the elongated back of the head. Okay, you can see that. You can see the protruding eyebrows that we don't have. They don't have a chin. The Neanderthals didn't have a chin. We're the only animals, especially on the hominid side, that has chins. And then they had big noses, bigger than ours. Okay, so if you saw this creature in the forests or in the jungles, you would run the other way. You would not decide to mate with them. Okay, that's the first thing that you really have to come to grips with. Okay, these were two different species, noticeably two different species. Then the other issue is that we had clothes and they did not. Okay, and that's one thing that, that's always missed. When we came upon the Neanderthals, if we ever saw one, right, we may have seen, Neanderthal here and there. They would have been undressed and we would have been dressed. They had no sandals or boots. They were with their feet completely on the ground, just like a wolf in the north, just like a bear in the north. They don't use sandals over there, And we had to put something on because we were not used to the cold, and we were moving into Arctic weather. Okay, so all this has to be kept in mind. But now you have another fellow. He says the following. Okay, keep that in mind. Here's this other fellow, and he says the following. He says, even less knowledgeable, he says, well, maybe we came after the Neanderthals and never lived in the same period. So you can see how these people never did any research on Neanderthals. That might be a better explanation for the lack of our DNA in Neanderthals. Dating methods are certainly not as precise as they think they are. Like physics today and other sciences, there are a lot of assumptions and quirky mathematical theories. Yeah, not because, of this, you're going to throw the baby with the wash water. It's not like we don't know anything about the Neanderthals. We have, I think they said like 70 skulls of Neanderthals. So it's not like we have millions of them, to do research on. But they could formulate some ideas about, about the Neanderthal, who they were and where they were. Okay, and what happened to them, especially what kind of tools they used. Okay, they had different tools than we did, than Cro-Magnon that came into Europe did. And then you have the issue there that you can see the human migration, at least as we think it happened. Again, this is an assumption. You don't have to accept the assumption, but if you accept this assumption that humans ventured out of Africa, went east to China and Indonesia. They found skeletons there as well, especially skulls, and then mandibles, right? And then if you go in the other direction, you go to Europe, well, you find the Neanderthals. And if we did it in a short amount of time, we could not have adapted to the cold. We were probably following some kind of herd, maybe, I don't know, maybe some ancestors of the cows today, or maybe we were following some other animal, maybe mastodons or mammoths when we went into Europe. And so, we had no adaptation to cold, and that's when approximately the time that we invented the needle. The first needles come to about 40,000 years ago, and they think that maybe around that time we started making clothes. Neanderthals, they were built from, or in other words, they descended really from Homo erectus. Homo erectus had already reached England, about 800,000 years ago. You go to Happisburg, you find clues that some kind of two-legged animal was around there. Okay, they found bones of mammoths that were killed. Okay, there. And there are several sites in England. And so, when you're talking about 800,000 years ago, you're not talking about Neanderthal. They weren't around, neither were humans around at the time. What they had at the time in the world, right? Where Homo erectus, maybe antecessor, which was the offspring, the evolutionary lineage of Homo erectus, and right after that came man of Heidelberg, Heidelbergensis. Okay, so you've got these different creatures there that were becoming some kind of human-like creature, more like Neanderthal, like humans, right? But at the time, they were more like monkeys, maybe. You know, they were out there with their skins. They had no clothes on, and they adapted to the cold. So if they adapted to the cold, by the time you get to Neanderthals, they were well adapted to the cold. They had no reason to wear clothes. They did not invent clothes. You find all these pictures with Neanderthals with clothes, and it's funny. It's like saying, you know, a monkey dresses with clothes. We might dress them, but they wouldn't invent clothes and dress themselves up like that, okay? And so here you get an idea. This is more or less what I'm talking about. Here you have Neanderthals. They evolved in the Arctic weather, whereas we evolved in sunny Africa. You could say it wasn't so sunny, but it was a little sunnier than the Arctic weather that you had in Northern Europe. And the lineage of Neanderthals came through Heidelbergensis, probably antecessor, which apparently antedates Heidelbergensis, right? And we allegedly, again, these are assumptions, you don't have to take them at face value, but we apparently came from Rhodesiensis or some other creature that stayed in Europe. Then we moved over onwards, northwards, and we ended up in Europe. Okay, probably following the again some kind of herd. Okay, hunting reasons. And so, you know, when we met Neanderthal, if we ever met him, you know, I doubt very much we would have made it with them because I visualize them as the woolly man. Okay, they were a little shorter, they were thicker, they had different skulls, they had no clothes, they really looked like chimpanzees, if you ask me, and we were a little different. You know, we were not as hairy as they were, and we were wearing clothes. That would have, you know, scared the hell out of a Neanderthal. What the hell is that guy doing wearing clothes? What is that? You know, they never saw such a creature. They were expecting some kind of, you know, hairy individual, and we had all these rugs on top of ourselves. So that's one issue. The other one is that I mentioned the other day, Neanderthals were never in the Levant. Okay, so you know, they say that we made it somewhere around Israel and Iraq. They found bones of some creature there, Neanderthal-like creature, in the Shanidar cave. And if you look at the analysis that these people did, and they were experts in that region, okay, Ehrenberg. And what you'll find about what they say in their article is that, you know, we were very different than the classical Neanderthal that you find in Germany and France and in Spain. So I'm not sure that what they found in Israel and Iraq were Neanderthals. They were some other creature that never was, that became extinct as well. Okay, and I'm not sure we made it with those either. Okay, so, you know, what can I tell you? You got to read a lot of these papers, and when you read a lot of them, you get a sense of what we really know and what assumptions can be, you know, you can put your hand in the fire for, and which ones you cannot. A lot of them are bunk, just a lot of nonsense. For example, the biggest nonsense that I see is that we traded with the Neanderthals, you know, that we gave them beads and they gave us their women or their 2 pounds of, you know, mammoth meat, or maybe a fur coat. You know, they think it's a trading post of some kind. And no, we never invented trade until the Neolithic. Before that time, there was no trade. When you have people like John Hawkes and Eric Tringhaus and Wolpoff, all these people, they talk about trade, they talk about mating, they talk about a lot of nonsense that has nothing to do with reality. They're pushing an agenda because they cannot explain the extinction of the Neanderthals otherwise. That's the issue. So it's what I call political science. They're just trying to get their theory through, and they say, this is what happened. And for that, they had to show not only that we swapped wives. I don't know why we would do that. Maybe their wives were a lot more beautiful than ours. I don't know. And And then we also traded beads for maybe meat or who knows what. So there's a bunch of nonsense out there that, you can't really trust at all. But you got to read a lot of papers to get a feel for it, and I don't think these fellows here did a minimum of research. They really should look at that more thoroughly before posting. You got to read a little bit about the Neanderthals. I mean, if you're interested in the subject. Okay, so here I show this fellow. His name is Svante Pääbo. He was given the Nobel Prize, I think at 21 or 22, for proving to the world that Neanderthals and humans mated. Okay, what did he find? He found between 2 and 4% of Neanderthal blood in our bodies, and he's inferred or deduced that the reason for that was that we mated about 40 to 50,000 years ago with the Neanderthals. Today, they extended that, a couple papers that came out recently, to 200,000 years ago. We had all this sex, with the Neanderthals from 200,000 years ago, again 100,000 years ago, and then about 50,000 years ago. They found 3 waves where we had all this sex out there in the wild. It's like tigers meeting lions, and instead of fighting, because they're different species, and in the wild they don't trust each other. There's no such thing as trust in the wild. But here, we mated with Neanderthals who were hunting game, and we say, hey, why don't we just drink some beer and exchange some women, and some meat, and I'll give you some beads or whatever. This is all total nonsense. But this is what these people believe in. The fact that we have Neanderthal blood can be 2%, 2 to 4%, very little, has to do with the fact that we had a very common ancestor a very long time ago, which was about 800,000 years ago, and which was Homo erectus. Okay, so this is political science. The other issue there is that, the mitochondrial DNA, we have none of Neanderthal mitochondrial DNA, meaning no human has ever had a Neanderthal mother. There's no evidence of that, okay? We had no Y chromosomes, okay? Meaning that no Neanderthal father passed the Y chromosome to a male human, okay? So we don't have either one of those, and no evidence that we had Neanderthal fathers or Neanderthal mothers. And then the Neanderthals have 0 human DNA, and I have no understanding of why they would not, but that's what they showed, and I can just go by what the experts say, what the facts that they found out there are. If they had no human DNA, then I'm not sure why they say we mated with them, It's just, again, the only reason for all these theories is that they have no theory for the extinction of the Neanderthals. And that's a wrap on the Neanderthals. Now, continuing with extinction, here we have a population issue, and a fellow says the following. He says, I don't know where you live, but where I'm currently, the Philippines, the schools are having to run 3 shifts per day to keep up with demand, and there are significant numbers of schools established in the past few years. The Philippines has a government department dedicated to what? Exporting surplus population abroad to European and Anglophone countries. Okay, so United States better beware. The Philippines has a program to export people. Okay, half of the population of India is under 25 years old. India alone could have massive die-off due to famine and cannibalism, and then repopulate the world. And that ignores a bunch of other high fertility countries. In hard times, female fertility rises, not falls. So-called civilization may collapse and the world human population dial back a bit, but unless something happens to make the earth non-viable for life, humans aren't going away. There are simply too many humans now. So this fellow says, my mother had, 15 kids, and my next door neighbor had 10 kids, and so the Philippines is exploding with people. They look around, they look at a very small bit of data, and they generalize from this tiny subset, right? And there's a danger with that, because what they should do is do some research on the real numbers, okay? And so let's present the real numbers for the Philippines, okay, which is what this fellow brought up, and here it is. These are the birth rate for the last 50 years or whatever, 40 years. No, I'm sorry, 80 years really. all the way to 2030 projected. And you can see how it's been dropping from 48 to these days it's around 20. Okay, so it's dropped by more than half. That's the rate. That's the number of kids born per population, per total population. Okay, so it's been falling. And here's the curve so that you can see it. Okay, and this is just again for Philippines. Okay, look at the blue line. Okay, the blue line means that the rate is going down, and down. Okay, it's been going from what it used to be in the in the 50s, about 140 per per 5-year period. Okay, all the way down to what it is today, which is about half there. To 20, 20 per 5-year period in millions. Okay, and so what happens? You see the population is look at that curve, the brown one. It goes from convex to concave. Okay, so it's making that curve, and it's flattening out. It's going into the asymptotic mode, and at some point it's going to drop. Downwards. It's going to go downwards. And you can see that also he mentioned India. Well, here you see China and India, what's happening to their populations. You can see that their populations are also, China has now reached the zenith and is coming down as far as total population in millions, right? And India has caught up with China. It's going to surpass it, but it's going to enter a period in which it comes down again. Okay, and the question is, why do all these curves end up coming down eventually? They reach some kind of asymptote, and then at that point they begin to fall downwards. And they end up like all other countries, most of them, Russia, which I mentioned last week, is trying to get their population restarted again. It'll never happen. It's impossible. They don't realize, the Russians don't realize that. Japan, again, it's impossible for Japan to ever grow again, okay, in population. And you have all these countries which are in negative population growth, and none of them can explain it. They say, let's put some program, political program, some incentives for women to have children, and it's never going to happen. And they don't realize why it's not going to happen, why all those curves are coming down, why China will eventually come down, why India will eventually come down, Bangladesh, Indonesia, Philippines, you name, whatever country you want to name, they're all going to come down. Okay, and here's the curve for the entire planet. In fact, I'm not just talking out of my nose holes. Here it is. World population growth rates. This is the global population. So I don't care how many people they're putting out in Nigeria and in Pakistan and some of these high growth countries. They're all coming down. Okay, the curve is going down. And unless you understand what this curve is telling you, right? You don't understand anything about population. You can't talk about population and say, oh, in the Philippines, we have so many people, we have to export them. No, even Philippines is losing people, okay? And not because of immigration. It's losing people because people are not having people. That's why. And the reason is only one, right? And the reason is urbanization. And here you see it. In fact, here's the question that, comment a person made here says, we're not having children. They could have fooled me. We are plenty, too many. It's time for massive reduction to save the planet and humanity from itself. And yeah, what's the issue? The issue is, again, this person doesn't understand what's going on. One issue is whether we're having children, and the other one is whether we're too many. Those are two separate issues, okay? And the too many is answered objectively. And a fellow who answered that was Thomas Malthus in the 19th century, and he had this theory, the Malthusian theory, when it says that, population will outstrip resources, right? And so you have to have resources keep up with population. And as long as resources keeps up with population, you don't have a problem. You don't have too many. You have too many when your population outstrips resources. That's how simple it is. So this notion that, that we're too many, that's an opinion, okay? You can't trust opinions like that, not in science. And then, again, you can see that if the population growth rates are falling and the population of the world is falling, then we don't have to worry about being too many. The issue is, why why is the population falling? And then you see it on the right. That's tells us exactly what's happening. We are becoming urban populations. Everybody's moving to the cities from the country because the country is being taken over by big corporations that are producing the food for all of us. So they have these massive operations, right? Economies of scale, where they can produce food for the whole population on Earth. And so, there's no need for the individual farmer that we had maybe 300, 400, 500 years ago. There's no more need for an individual farmer. Right now, corporations have taken over that. And you can see the rural population of the world is coming down, and that explains the collapse of the growth rate. Okay? So what's the issue? The issue is that population of the world is not going to grow forever. We don't have to worry about doing anything about it. The old people will now begin dying because usually, not too many people live beyond 100. In fact, few even live to 90, right? Lots of them, but lots more than in the past. But, we usually die in the 80s, 85, whatever. And a lot of people are now old. The population of the earth has become old. We're an old species in that sense. Most humans are old and they are beyond reproductive age. What's happening is the group that can reproduce, maybe between 20 and 40 years of age, they're not very productive because they live in the cities and they produce 1 or 2 kids, which does not replace the population. And that's what's causing the population of the world to fall. And yes, the more people move into the cities, the less children we'll have. Cities are no place for children. Okay? It's not like in the country they had 10 kids and was okay. Half of them died and 5 lived and the population kept growing. That's not happening anymore. Right now, we're having 1 or 2 kids at most, and that's it. And not everybody does that. And a lot of people don't even want to have kids. Many women have completely abandoned having kids. They think it's an animal practice, like having a kid. What do you mean? Are you thinking I'm an animal? So, we're not having kids, and lots of women are foregoing having children, and that's also depressing the growth rate. And so all I can tell you is the population of the earth, whole earth, I don't care what country you talk about, but the entire earth is going to go down eventually as the growth rates keeps falling. And it is not falling because there was a war or a disease. It's falling steadily because we're not having children. And then obviously the old folks will be dying at some point, more and more of them. We're going to have higher death rates and lower birth rates. And that's the final collapse of the human population. But we'll never reach that point because we're going to have something that happened before that, which will be total collapse of the global economy, and that will be the extinction of man. Okay, so we had a couple questions on another issue. I'll just touch upon them real quickly. One is the word exist. Very important in physics, so I always touch upon the word objects and exist. And a fellow says the fundamental is existence. Whatever an alleged elementary particle or force may be would be existence. No. Particle maybe, force no. Force is a concept. Concepts cannot be said to exist in science. Okay? When you say that force exists, you're talking about ordinary speech or mathematics. One of those two, but you're not talking about science. Now the fellow says, nouns are secondary. The verbs are primary. Matter needs motion to exist. Absolutely not. You need to look for verbs, not the nouns. No. Motion, 2 locations of an object. Okay, so you need an object to define motion. The object comes always before motion. You need the horse before you can talk about the movement of the horse or horse racing or whatever. You need the horse. So first you need the object. And exist does not require motion at all. Okay, look at the definition of exist. See if you can find any motion in there. It says physical presence. Okay, object that has location. Location is a static concept. There is no motion. If you want to have motion, you need two locations of an object, right? Then you have motion. So no, exist does not require motion at all. There's no provision for motion in the definition of exist. Exist, in fact, is not a verb. Exist is an adjective. It qualifies object. It says that an object, in addition to having shape, has location. Okay, so it's a qualifier of object. Exist is a static concept. Exist is an adjective for the purposes of science, not a verb. There is no motion involved in the word exist. If God wants to exist, very simple. God first has to be an object. Okay, so for example, if you take Michelangelo's God there, that's an object, got shape. Okay, so qualifies for the first part. Okay, meets the first part of the specification. What's the second part of the specification? There has to be location. In this case, if we are the only two objects in the universe, God and me, right? There's got to be separation between God's finger and my nose. My nose. Okay. So as soon as he points to my nose, we have distance, we have separation between the surface of his finger and the surface of my nose. Now God can be said to exist. What does that mean? God does exist? No, it just means that now we can use the word exist. We can say, does God exist? Yes, for the purposes of my theory, the one I'm going to base on this word exist, God exists. Why? Because he meets the two criteria. He's an object and he has location. In this case, distance from me. Okay, there's a separation. There's a straight line of direction between me and God. Okay, so now God exists by definition, not because I believe or stop believing in him. Okay, so God exists by definition. Now I can say, look, let's assume that God exists. Okay, and now I can base a theory based on that assumption. The assumption includes the definition of exist, and exist is physical presence, object with location. Okay, so only then can God be said to exist. That's the context in rational science. In mathematics, well, who knows what it is? They say everything exists that they want for it to exist. Okay. Okay, and then another fellow says the following, talking about entanglement, he says, I think entanglement is not faster than the speed of light. Even mathematicians do not agree, because if you torque one rope, the torsion would travel at the speed of light. How can it be faster? And so, yeah, let's make sure we understand. The rope that extends from the last atom in the universe to the other side of the universe, to another atom on the other side of the universe, that rope, right, that extends from one atom to the other, two opposite sides of the universe, can twirl in only one direction. It either twirls from one point of view, right, clockwise or counterclockwise. You cannot twist the rope, right, and then wait for the whole thing to untorque from one atom to the other. That's not the way it works. The way it works is the whole rope twirls in one direction or the whole rope twirls in the other direction. Okay. Now, what have they done? Well, they've done an experiment, like the famous one by Alain Aspect. He was a French physicist, mathematical physicist, who ran an experiment on EPR, Einstein-Podolsky-Rosen, which is entanglement, essentially. And they said, yeah, in fact, it does happen. They said they measured at a certain place, right? And they found that here it's clockwise and there it's counterclockwise. Then they switched around. They had counterclockwise here, and they said instantaneously it was counterclockwise at the other end. So you say, well, then, they untwisted the rope, and that was instantaneous on the other end, but then that's faster than the speed of light. And so what's the problem? Problem is that we cannot measure a single rope, let alone touch it. There's no way you can measure it. So they cannot tell you exactly for one rope, okay? For one rope, they cannot tell you if it's going clockwise or counterclockwise. So all these experiments that they've done, like the one that Alain Aspect did, have to be revised, not in terms of particles anymore. Now you have to look at them in terms of the rope, okay? You've got a different proposal, and those experiments have to be reevaluated under the new proposal. Okay, so what Alain Aspect did, and all these other people who repeated his experiments, is nonsense. Not the experiment itself, but the interpretation of the experiment, which is particles. And they say, well, how can the particles travel faster than the speed of light? That's impossible under special relativity because nothing can travel faster than light, for otherwise it become energy. And so the conclusion is that there's nothing between the particles and that there's this mystical influence, witchcraft. They call it action at a distance, which is the scientific version of black magic, witchcraft, voodoo, physics, right? And they said there's nothing in between, but we prove that there's instantaneous influence. Yeah, now we have to revise all that. We have to revise it under the rope model. If you got clockwise over here, on this other side, you would have counterclockwise and see them from the other, from opposite ends, and vice versa. If you measure something clockwise over here or counterclockwise here, you would see the opposite. Okay, but you cannot chop a single rope and say, oh, I've concluded, I discovered, I proved that, here's clockwise over there, it's counterclockwise, and when I turn this one back counterclockwise, this one goes clockwise. You can't do that because there's no way to measure a single rope. We have no ability to do that. And so, again, we have to look at, all these experiments all over again under the new proposal, which is the rope model. Now, just in case, here's another incident of what is called action at a distance, which is gravity, and which is the reason they never have been able to explain it so far. And here it is. What do we have? Do we have instantaneous gravity? Yes, the answer is yes. It's instantaneous. And you say, how can it be instantaneous? Well, the first part of the problem there is the word instantaneous. Instantaneous has to do with time. And there's no such thing as instantaneous time, because time takes at least 2 frames, because you're comparing 2 motions, and motion is 2 locations of an object. You can't have 2 locations of an object in a single frame of the universal movie. So we have a problem there. So how can it be instantaneous? So we're going to use the word instantaneous with the understanding that there is no such thing as instantaneous. Okay? What we're saying is there's a complete... there's only a single frame in the universal movie. And in the single frame, right? In the single frame, you're going to have this. You're going to have, here you have 3 frames. Each one is a single frame in the universal movie. And you can see the astronaut has a certain distance from the Earth, and you have a certain number of ropes. As he approaches, all the ropes that are tied from every atom on Earth to every atom in his body fan out. They separate. They're not on the same axis anymore. Many ropes are on the same axis at a certain distance. As he falls, the ropes keep branching out. They continue to separate. The closer he is to Earth, the more they separate. And the more ropes that act independently, the faster he goes. And that explains the acceleration of gravity. And that is instantaneous, to use that word. Why? Because once you're in a different location, the separation is instantaneous in the sense that, there's no time involved. It's a question of distance, and distance is a static concept. We're not talking about distance traveled. We're saying that the location has changed. And by changing the location, the ropes separate. And that's instantaneous in the sense that it fits in a single frame of the universal movie. Okay, so in that sense, it's instantaneous. You have to understand the word instantaneous, instant, simultaneous, all this other stuff that refers to time. And they invented these words like simultaneous and instantaneous, but they never defined time, let alone these other words that are dependent on time. So you got to keep all this in mind when you're talking about instantaneous. When you change location with respect to the Earth, the ropes instantly, immediately, from frame to frame, change their the number of ropes that are acting independently. And that's instantaneous in that sense, if you want to use the word instantaneous to refer to that. I don't know if there's any other word to refer to it, but I just want to keep in mind the word instantaneous is very tricky. Okay, you got to keep it in context of the rope model. Okay, and so both all these action at a distance, like entanglement and gravity and If you want to consider it the gluons mediating between quarks inside the nucleus of the atom, all these are elongated things that are in there. Okay, you cannot talk about nothing being between two objects and one object influencing the other. That's known as black magic. There is something there that we cannot see or touch. That doesn't mean that there is nothing there, which is the version that quantum mechanics has today. Okay, let's move on to the subject matter of today, and that is whether physics is math and math is physics. Are they synonyms? Is that what physics is about? Just math equations, we measure, create some standards, and then just put out a value and say, that's physics, I did physics. So what do we call this? You know, here you have a pen, okay? And it falls to the floor, right? There it is. It just falls. We all know what happens with all this. Here it is. You know, one more time. We got to do repeatable for it to be scientific, right? According to mathematicians. Here it is. We let go of it, and it falls to the floor. Yeah, it always falls down. Never falls to the ceiling. Okay. I don't know if you noticed that, but you can try it at home. Very expensive, very dangerous experiment. Do it in the presence of a relativist always. Anyways, if that falls, is that a question of physics, or is that a question of philosophy? And so some people will say that it's a question of philosophy, that it has nothing to do with physics, because physics is only about equations, about measuring, about math, about numbers and variables. That's what physics is about. And so we have first a couple problems. You know, what do we do with this? Where do we put this incident, this physical phenomenon? You know, it always falls to the floor. And here you have another one. You have magnets. One attracts the other, right? You can see that, the two magnets there, and they attract each other. And so these qualitative phenomena that we observe daily, like, you know, falling of a spoon or magnet attracting another, is that philosophy? You know, the cause, the mechanism, how it works, the physical interpretation. We call it physical interpretation and say it's philosophy? And then the third issue is, okay, if it's philosophy, why are the so-called mathematical physicists answering these types of questions? Why do we ask them these questions if they're on record saying that they don't do this kind of work? They do math, they do equations. Why are we asking them these questions? You take people like Sean Carroll, and you have people like Sabine Hassenfelder and Brian Greene, and all these people, Neil Tyson, and all these people are answering qualitative type of questions. People are asking them these questions. These people are trying to answer these questions. They never give you an answer. And the ultimate answer is, oh, by the way, that's just philosophy. That's not part of physics. That's not what we do. What we do is equations. And so we have all these levels of problems. First, is physics the same thing as math? Are they just equivalent? That's all they do, just equations. If that's the case, you know, what do we do with all these other physical phenomena like gravity and magnetism, light, the workings of the atom? Where do we put those? Philosophy? And if it's philosophy, why are the so-called mathematical physicists trying to answer these questions? Okay, so we have all these levels of problems, right? And so let's find out what people have to say about it. Here we have some comments that people made this week about my last presentation, my last lecture, and I think they speak for themselves here. It says, mathematical physics have a very specific meaning. It covers all the problems that can be expressed as Cauchy problem, and nothing else. Heat equation, example heat equation, it works. Yeah, the fact that it works does not mean it's part of physics. If it works has to do with technology, and technology is not science. Okay, technology is developing gadgets by trial and error. Science is explanations, rational explanations. So the fact that it works has nothing to do with science. Okay, and here we have another fellow. He says, we observed that a spoon falls, and we then check it to see how the data we collect on its falling correlates with what? Theories of what is making it fall. Okay, he's talking about the theories, the explanation, the causes of what is making it fall. These are his words, right? I didn't put that in there. He said that. And says, we check Newton's inverse square law and we find very good agreement. Yeah, that's a description so far. You're not telling me anything about a theory of what's making it fall. In fact, Newton admitted he had no idea what's making it fall. This means Newton's theory passed the test. No, he didn't pass any test. The test is what is making it fall. There, we're using your own language. If we do lots of tests and Newton's theory keeps predicting accurately, we say the theory is likely correct. So far, he hasn't had a theory. He hasn't proposed a theory. The fact that you can predict, which is just a description, does not tell you anything about what is making it fall. So we find that Newton's theory doesn't exactly predict the measured perihelion of Mercury. Einstein explains all the things that Newton explained. Talks about explanation. See, he's using the word Einstein explains, Newton explained, right? Perfectly, and it also explains, once again, the perihelion of Mercury. It has also passed every other test that's been thrown at it for the last 110 years. That's how we know, it is probably a true explanation. Again, explanation. So far, we have no explanation. He hasn't talked about any explanation. The explanation that Einstein provided was that we have warped number lines. And the explanation that Newton provided, which he said he had really no explanation, but he says, but he did everything with particles. So he could not explain with particles how the moon attracts the earth, how the sun attracts the earth, and all the planets attract each other. You cannot explain that with particles. And that's why he said he had no, hypothesis. And then he says, that's how we know it probably is true, a true explanation. And again, this person doesn't have an idea what he's talking about. He doesn't know what an explanation is, and that's going to be the subject matter later on today. But explanation is that what he said at the beginning. Theories of what is making it fall. That's an explanation, okay? And then so he just talks about math and the fact that experimentation gives us some equations, tells us how something is moving, but there is no explanation as to what's causing it to move like it moves. That's an explanation. That's what science is about. Not the fact that you measure something and say, oh, the pencil fell to the floor at 9.8 meters per second square. That's not science. That's like measuring a table and says, oh, the table is 1 meter and 1 micrometer long. Right. Is that science because you measured the table more accurately than the other guy who said it was 1 meter? You measured it more accurately. You got a better caliper or whatever, and you say, I measured it much better than the other guy. So you get a Nobel for that, for measuring it better. Okay, here's another fellow, and he says the following. He says, you talk about how mathematics can only describe, as if that somehow invalidates its usefulness in physics. They talk about use. They're talking about something else. They're talking about, technology. They're not talking about science. Science has nothing to do with usefulness. Science is not useful. Science is only there to understand how this universe works, okay? There is no usefulness. And what he's talking about, again, equations, okay? That's why he says that it's useful in physics, because he brings equations into physics. Yeah, we don't use equations in physics. Physics is qualitatively only. You have to explain what causes this pencil to fall to the floor. That's what rational people want to understand. Mathematicians, who are irrational people, they want to understand how much, how fast, how much it weighed, how much time it took. They're into something else. They're not into physics. I'd be interested to see you attempt to, describe, uses the word describe, right? In detail, even the most basic, physical interactions in nature without mathematics. Yeah, mathematics is about description. We don't care about that. We do explanation, not descriptions in science, in physics specifically. Let alone make predictions. We don't do predictions. Predictions is astrology. We don't do predictions in science. Palm reading, foretelling the future, you're in the wrong business. Whether it's words in mathematical language, you're still using the same principles of logic and reason. Okay? But I like what he says next. You'd think someone that objects so strongly to the use of constructs like fields in physics would value a formalized language for logic and reason over imprecise everyday language. Okay, let me show you the precise language that mathematicians use. Here it is, okay? See if you can find any precise language here. Here it is. Let's put this one here. Energy. What is it? It's the quantitative property. That's what it is. And then they tell you that they're going to transfer this property. How do you transfer a property? I mean, if it's just a characteristic of something, how do you transfer a characteristic, which is what these people are saying when they give you their physical interpretations. And then you have mass. And what do you find in the Wikipedia? There's at least 7 different aspects of mass. There's 7 different notions of mass. Okay, so they don't have any definitions. In fact, look at what Feynman says about energy. It is important to realize that in physics today, we have no knowledge of what energy is. And again, Feynman was not smart enough to realize that energy is not a what. It's not a noun. Okay, energy is what a quantitative property. And yeah, that way you cannot say that you know what energy is because it's not a what. It's not a thing. Okay. Then you have force. What is it? Force and influence. Great. What is time? A continued sequence of existence. So if you persist, then you have time, whatever that means, right? Because you can see how they define the word time in terms of past, present, and future. You look at past, present, and future, and guess what? You find out that it's defined in terms of time. Then you get the word field, a physical quantity. And they shake this. They say the physical quantity is vibrating. And when it vibrates, it turns into a particle. So, if a field is a physical quantity, you cannot use it as a physical object in science, okay? So, we have all these people who define these terms, the mathematicians, and they never realized that what they were defining as concepts, then they use these concepts as physical objects, and so they have all completely imprecise language. That's what they ended up with. And so this person talks about logical and precise language when mathematics does not have a single word related to physics, which they claim are related to physics. Not one of those is defined properly. We don't have scientific definitions from anyone in mathematical physics. Okay, so not only are they introducing words into physics, but none of their words are defined to begin with. So we have undefined words introduced into physics and treated as physical objects. They're going to move the mass, they're going to transfer the energy, they're going to vibrate the field or shake the field or talk about the excitation of the field, and they say that's a particle. So what is a field? A bunch of numbers, and they say that a bunch of numbers vibrating, that creates a particle. All completely nonsense. None of those terms have been scientifically defined. Okay, so how do we do it in science, in real physics? Well, the main thing is that you have to define what I call the foundations of physics. You have to lay the foundations of physics. And the first item there is the golden principle of physics. You have to lay down the golden principle of physics that you can't do physics without an object. What would be going on in the universe if you wiped all objects out of existence? If there's nothing there, what would be happening? What would you be measuring? What would you be testing? What would you be observing? What experiment can you run? You can't do anything because there's nothing there. So hopefully the first thing you need in physics is objects. You need objects, okay? And so the foundations of physics involves the definition of all these words. You need to have these words if you're going to give a physical interpretation, which is what physics is really all about. That's what we're going to argue today. And you need to define the word object, that which has shape, not that which you can see or touch. So whenever people raise issues of how come you can't touch this, how come you can't see this, well, now you're talking about nonsense because the definition is not see, touch. The definition is shape. Okay? So something can have shape doesn't mean you can see or touch it. We can't see the air even though it's made out of atoms. You can't see the table of the ET that's on the other side of the universe. Okay? Does that mean the table's not an object, not a thing? Yeah, it's a thing because it has shape, not because you can see or touch it. Okay? And shape, all objects in the universe had better have shape. Okay? Because if there's an object that doesn't have shape, please show it to me. Make a drawing of it. Okay? Illustrate it. Space, that which doesn't have shape. So if a thing is that which has shape, nothing is that which doesn't have shape. Antonyms, you can use them scientifically now because one is the opposite of the other. Distance, separation between two objects. Okay, you need the word object to define distance. You need two of them. Separation, that's distance. What is location? The set of distances from one object to all the others in the universe. Okay, so we have, that's the location of that object with respect to all other atoms in the universe. So if you take any atom, I don't care which atom you want to pick in the universe, the location of that is with respect to all other atoms in the universe. And it's a set of distances. So now we have a definition for location. You can also use the word location for any subsystem. You can take any object. You can say, what is the location of the pen in the room? Okay, you can do that. And you can just say, well, okay, there's distance with respect to all these atoms in the room. You can also take big chunks like, say, the wall, the roof, or whatever. You can say there's distance between the roof and the pen. There's distance between the wall and the pen. That's the location of the pen inside the room. So you can use it for subsystems as well. Exist. What is exist? We just covered that. Physical presence. Object that has location. Only then can an object be said to exist. It has to be an object. It cannot be a concept. You cannot say that intelligence exists, especially in Cambridge and Harvard. And you cannot say that love exists. You know, love does not exist in science. Okay? It exists in poetry only. Motion, two or more locations of an object, and concept, a word that invokes or embodies two objects. And a rule of thumb there, the quick way of telling whether it's an object or a concept is, can you draw it? Does the concept have shape? And hopefully there's no concept that has shape. You know, love, what are you going to put, a heart? Yeah, if you put a heart, the heart is an object, but that's a pictorial representation that we gotten used to as a representation of love, of the concept known as love. But heart and love are two different things. Heart is a thing, love is a concept. So you need to separate all these words. You need to define these terms. And once you define these words, we're done. Now we can use them rationally and give physical interpretations, which is what physics is about. One fellow says, math is defined as the science of measure and number. A number is a name given to a measure that describes a ratio of magnitudes, according to John Gabriel. Okay, so I looked up John Gabriel, find out what he had to say about number. He says the following, says, after Euclid and before me, no one understood what is a number. So he says he's the guy who essentially rediscovered Euclid's definition of number. Okay. And he says a unit, this comes from Euclid, a unit is that according to which each existing thing is said to be one. Okay? Unit is one, great. Okay? One is unit, unit is one. Sounds like a circular definition. Okay? Number is just a multitude of units. Okay? And, no, I sent the letter to Mr. Gabriel, and he hasn't answered, but this is what I say. I say he did not discover what a number is. Okay? And so let's go through this real quick so we understand what math is, what the foundations of math are, which is numbers, right? And you have number is not the same thing as numeral. Okay, there are two different things. Numeral is the symbol. Okay, the symbol 5, right? That's a numeral. And what does it represent? Well, it represents the number of times you waved your hand back and forth, up and down to count something. So you count units. In that sense, Euclid was right, but the emphasis is not on units. The emphasis is on counting. Number is a verb. It's not a noun. Number means to count. That's what it means. Okay, and so these people are focused on units and saying, well, we have many units. Yeah, no. Number is the verb to count. You have to be counting. Number is a dynamic concept in great measure because you are comparing 5 against 4 against 3 against 2. 2 is not the same thing as 3, 4, or 5. Why? Because what you're doing is moving that finger up and down, and you're giving names to each one of those representations. So if you're moving it twice, you call that a 2, and you're moving it 3 times, you call it a 3, and so on down the line. So you give a numeral, a symbol, to represent the number of times you moved your finger. But what does that numeral represent? Counting. How many times you counted something. Okay. Okay, and fellow that we need to bring this up as well brings up the issue of zero. Says zero is not a number. Counting starts at 1. Measurement starts at 0. Get 0 off the number line. And he's totally right. Totally right. 0 is not a number. You cannot have either 0 or negative numbers. Again, so it says it does not exist as a value. It's a balance between two positive magnitudes. Negative numbers don't exist. You can't have negative magnitude. And yes, again, negative numbers were invented for accounting purposes. You know, I owe you 3 apples, so I have a negative 5 apples. Or 5 apples or 10 apples, you know, because I owe you. And so it's just an accounting issue. And so they put a negative sign there saying, okay, if you owe me, then you have negative. And so they started working with negative numbers. And yeah, you cannot have negative numbers because that just means I owe you. That's an accounting practice. It has nothing to do with the real number system, which is, you know, 1, 2, 3, 4, 5 to whatever number you want to count to until you get tired. Okay. And so, yeah, we have a problem because they introduced negative numbers, and then they introduced, again, all these values. In fact, one of them is the irrational number, which is square root of -1. And that's a long story. So, you know, you can't have negative, you can't have a negative square root of number 1 because you would get a -1 and a +1. And so you would not get either or. You would not get two plus ones or 2 negative ones. Either one of those would give you would never give you a square root of -1 if you undo that. But the point is, they invented all these irrational numbers. They invented negative numbers. They invented 0. They invented a bunch of stuff that has nothing to do with the real world. Okay, there are no such thing as 0 apples. Because 0 apples is the same thing as 0 trees, 0 rocks, and 0 houses. They're all 0. Okay? I can't tell the difference between 0 houses and 0 apples. I can tell the difference between 1 house and 1 apple, but not between 0 houses and 0 apples. Okay? Anyways, okay, so let's get going here. Where did all this nonsense start? Well, as always, all the nonsense started with the Greeks. And instead of brushing all that aside and starting all over, they just continued with that, just modifying it over the years. And here we have good old Aristotle, and he said he's the guy who defined physics, the word physics, okay? So in a way, we have to respect that because he invented the word physics, which just means writings on nature. That's what he apparently labeled his book. But from there, they went and said, well, what he did was natural philosophy, and what we do is science, which is physics, and it's totally different than what he did. Why? Because it includes experiments, which Aristotle did not do, and we have more sophisticated math. We measured things, and he didn't do a lot of that stuff. Okay, so what did Aristotle think physics was about? Well, if you go to his book, he's got, it's eight books into one, right? The physics book contains 8 books, each one with chapters and so on. And what Aristotle talked about was these things. He talked about matter, what a thing is made of, object, right? Things, right? Place, position, he called it, or location, the site occupied by an object, essentially, right? Space, he think there was no such thing as a total void, because as soon as a void becomes available, something occupies it, so everything is always constantly filled. Everything in the universe just moves around by pushing or, you know, displacing whatever was in that space, right? So if I move my hand, what I'm displacing is all the air that occupied that space, and so there is no real vacuum. What I'm doing is just pushing stuff that was in the space that my hand occupies now. That's essentially the notion, okay? And motion, he said it's potentiality that becomes actuality. Something has the potential to move. When it does move, when it carries out that, you know, becomes actual, what was potential becomes now actual, he called that motion. So, yeah, that's a funny way of looking at motion. We call it 2 or more locations of an object, okay? But he says it's potentiality that becomes actuality. And time is just a quantification of motion, quantity of motion. That's what time was for Aristotle. And what Airy did was he established the difference between a mathematician and a physicist because of this, right? And so this is what he's had to say. He says, the next point to consider is how the mathematician differs from the physicist. Okay, so he's going to talk about that these two guys are different people. Okay, the physicist is not a mathematician or vice versa. Obviously, physical body contains surfaces and volumes. What is he talking about? Things, okay? And he says volumes, lines, and points. And these are the subject matter of mathematics, okay? So he's saying that the thing belongs to physics, but the volumes, the lines, and points that the mathematician is going to use, that belongs exclusively to mathematics, okay? So we have a separation between the objects, the things, how something moves, what location it has, those belong to physics. And what belongs to mathematics are the analysis, quantitative, the relations between, lines and points and etc. And he says it seems absurd that the physicist should be supposed to know the nature of sun or moon, but not to know any of their essential attributes, particularly as the writers on physics obviously do discuss their shape, right? Also, and whether the earth and the world are spherical or not. So what is he saying? That the things, essentially, any discussion of things, location, existence, thing that has location, all that belongs to physics. And what belongs to math are the analysis, the quantitative analysis, the relations. You establish standards and you compare things. That belongs to mathematics. So he established that difference. And that difference was really switched around. They converted all that into, the relations, they converted that into physics. And physics they relegated to philosophy, or what they call metaphysics. Here's Metaphysics, another book written by Aristotle, right? And he called it first philosophy, or the study of being qua being, okay? Being for their own being's sake. And he was talking about existence, knowledge, wisdom. He had a hodgepodge of notions that he analyzed in metaphysics. And so people say, well, see, all this stuff, that belongs to philosophy. They essentially equated metaphysics with philosophy. And the problem there is, especially that first word there, existence, that belongs exclusively to physics. Physics is the science of existence. Physics only deals with what exists, okay? And so for them to put the word existence with metaphysics, meaning with philosophy, that's where we run into trouble, okay? Philosophy does not deal with existence. Philosophy is something else. They never defined it, so we have to define it for them. Philosophy is explanations of behavior, okay? Philosophy talks about purposes and reasons why someone did something. That's philosophy. It has nothing to do with existence. Existence belongs exclusively to physics. And the reason all these people run around in circles talking about whether God exists or not is because they put existence into philosophy. And they think they're philosophizing. They're not. When anyone touching the word exist, whether they know it or not, has crossed the line over into physics. Okay? Only physics deals with existence, what exists out there. Okay, and just to mention this, we have this is a fellow by the name of Pythagoras. He came way before Aristotle, and he had a theory of numbers. He's saying that all objects are numbers. So he's saying an object is a number. A tree is a number, okay? And the only thing I'm going to say there is no such thing as theory. In other words, explanation in mathematics. Okay, so when he has a theory of numbers, that's a total contradiction. Theory is an explanations. Numbers do not explain. Numbers only describe, okay? And that's all that math can do. So we, again, start on the wrong foot because all these people confuse the word description with the word explanation. They think they're synonyms, okay? And no, they're not, okay? So let's just get some of that straightened out. Okay, so let's see some of these definitions today. What came out of all this work by the great scientists of Greece, and in fact, all those that came after. Here it is. Well, we have this from the Wikipedia, okay? The peer-reviewed encyclopedia, right? Because you can't put anything in there unless it's peer-reviewed by people who control the article. So it is a peer-reviewed encyclopedia. People sometimes dismiss, oh, you found that in Wikipedia. Well, you know Wikipedia. Anybody can write in there. No, not anybody. Because as soon as you write something, you'll have 100 people who will say, we're not going to let you put this in our article. So you have people controlling each article. And especially in the mathematics, all these mathematical concepts, they're peer-reviewed. Okay, anything that is not peer-reviewed does not enter the Wikipedia. In fact, no one has ever put the rope model in there, and someone tried to do that, and it was rejected because they said, well, it was peer-reviewed because, my article has been peer-reviewed by the IEEE, right? And they said, well, it's got to be there's got to be at least 2 articles. There's only 1 article, so they just said with that, they rejected it on that basis. So yeah, Wikipedia is peer-reviewed. They will not allow the rope model to enter there, at least for the time being, right? And so what is physics? Well, this is, according to Wikipedia, the natural science of what? Matter. Okay, so far, pretty close, because matter is objects that exist. So yeah, physics does deal with objects that exist. But then it continues as involving the study of matter. No, in physics, in science, we do not study. Okay, anybody can study and not know absolutely anything. You can study all week and get a 0 on the test on Friday. That doesn't mean that study turned into science, into knowledge, or whatever you want to call it, understanding. Okay. And then its motion and behavior, what? Through space and time. Now, you cannot move through space and time because space and time are not physical objects. You can, you're not moving through an ocean. You're not moving through air. You're not moving through a volume there that contains something. Okay, space is nothing. Time is even worse than nothing. There's no such thing as time. Time is a relation. So you can't say that you move through space and time. So physics doesn't study motion through space and time. And the related entities of energy and force. No, energy and force are not entities. Entities is a synonym of objects. Thing, entity, object, anything, body, substance, they're all synonyms in physics. There's no difference between them. Okay? And so energy doesn't, or force, they don't fit the mold. They don't have shape. Energy is not a physical object. Energy is a concept, a mathematical concept. It's an undefined mathematical concept. No one has ever defined the word energy in a way that they can use it rationally. So the word energy does not belong in science. It belongs in religion, completely in religion, in the religion of mathematical physics. And the same with force. Force, they have 4 forces, which I call the 4 horses, right, of the apocalypse. These 4 forces. And I'm not sure what they could have invented because you only have push and pull. That's the only 2 forces, only forms of contact that we can imagine. Either you pull or you push. And there's no other way that you can have physical contact. And what they're saying is they discovered 4 forces. And what are they? Well, you have the gravity, which is pull, and you have the gluons, which is also a force of pull. So I don't know how the gluon differs from the force of graviton when they both pull. And then you have the force of the photon, the electromagnetic force, which pushes, and you have the weak force, and that's also a push force. So I don't know what's different between the weak force and the electromagnetic force if both of them are push forces. There's only 2 forces anyone can imagine, push and pull. But they discovered maybe and perhaps. Great. Okay. Anyways, mathematics, a field of study. Now again, if you can study all you want mathematics, not understand anything, and that doesn't make you a mathematician. Okay. And what organizes methods and what theories and theorems? No, there are no theories in mathematics because theory is an explanation. It is not a description, and math can only describe. So you cannot say there are theories in mathematics. There are no theories in mathematics. And what is a theorem? Well, it's a statement that has been proven. And prove it to whom? To the Pope? To the Dalai Lama? Who did you prove it to? I mean, all these so-called theorems are just, they're tautologies. What's on one side of the equal sign is the same thing as on the other side of the equal sign. So there's no proof, what they call proof. Proof means that you are going to convince someone of something. And you can try to convince a born-again Christian that there's no God, and he's going to continue believing that there is a God. So proof is a matter of opinion. It's called, religion, opinion, whatever. Just your personal opinion of something, that your personal belief. That's all that proof is. That's all that knowledge is. Knowledge is the same thing as belief. And so when you look up the word theory, it says a rational type of abstract thinking about a phenomenon or the results of such thinking. So I'm thinking about the cake and ice cream I ate yesterday. That was a phenomenon, and it was very good. So is that a theory, what I just said? Because I liked the cake and the ice cream I ate yesterday? So no, this is not the definition of theory. Theory is a synonym of explanation. We need to define the word explanation. We'll know what a theory is, which is just a synonym. And in fact, they say it later on. They say in mathematics, the term theory, right? Listen to this. The term theory is used differently than it's used in science. Since what? Mathematics contains no explanations. It says it right there, same article. So we have a problem because they say theory is just an abstract thinking. And then they say, well, mathematics, they use the word theory a little differently because in mathematics, theory is not an explanation. Meaning that's what theory is, an explanation. And so the mathematicians call their descriptions theories. They call their descriptions explanations, and they have this notion that explanation is a bunch of descriptions. That's where the problem is. No, an explanation is not a bunch of descriptions. Explanation differs. It explains that because it deals with causes, something that a description does not. Okay, that's primarily the difference between them. And we'll get to that in a second here. Here it is. This is the Wikipedia again saying that that math has something to do with predictions, or that physics has something to do with predictions. And it says mathematics is used in most sciences for modeling phenomena, okay, which then allows predictions to be made from experimental laws. So I don't know what experimental laws are. We don't do any experiments in science, and especially in physics, and they talk about predictions. So they say, well, we got this equation, so we already measured this 1,000,000 times. We can now predict because we measured it, we've got the numbers, we've got the units that we made for it. We know what's going to happen if we repeat the experiment. Okay, that's what they're talking about. And what does that have to do with science? Science is about understanding, not about being able to describe something and say, this is going to happen because we measured it 1,000,000 times. You weigh the elephant, it weighs 5 tons. Okay, so we put him on the scale. What's he going to weigh? Well, he's going to weigh 5 tons. And if he eats, a bunch of grass or whatever he eats, we put him on there and we weigh the grass before he eats, and we say, well, this weighs, 50 more pounds. Now the elephant's going to weigh 5 tons plus 50 pounds. Great. So you can predict. That's science. They call that science. No, prediction is just a description. And it's not equal to science, because what? Science is rational explanations, not descriptions. Prediction without more is just a description. You can predict that tomorrow there's going to be an eclipse of the sun, right? The moon's going to pass between the earth and the sun. And so far, if you just say it's going to happen, you haven't explained anything. You haven't explained why. The moment you explain why, you're talking about the past. Why is always have to do with the past. Okay? Science is only about the past. You are explaining a consummated event. What are you explaining with this prediction that happens in the future? You're explaining what you already measured in the past. You already had an experience with eclipses. You finally figured out why that happened, what the cause of it is, the moon going between the earth and the sun, and you know that it's going to happen once again. So you predict and say at such and such hour, this is going to happen again. Why? Because we know that by this time, the moon has to go right between the earth and the sun. So now you have an explanation. Why do you have an explanation for this prediction? Because you're basing it on your experience. Experience is always past tense, never future tense. Okay? Physics is rational explanations of what? Causes and mechanisms. Only then you have an explanation. Okay? Okay, so here is the science definition of Wikipedia. See if they're even hit that one on the nose. Science, a systematic discipline that builds and organizes what? Knowledge. I thought knowledge was belief, justified true belief. In fact, that's what good old Plato defined it as, justified true belief. That's the translation, essentially, of Plato's book, right? And when you look up now, it says, despite agreements about the general characteristics of knowledge, its exact definition is disputed. So we don't have a definition of knowledge because they have opinions about what knowledge is. They have theories of knowledge. They never define the word knowledge. They don't have a definition of the word knowledge. And when you look it up, it all comes down to belief. Knowledge means just stronger belief. That's all it means. When you know something, when you know your wife cheated on you, you have a very strong belief. That's all you have. Maybe you're wrong, but that's your knowledge, right? And then in the form of what? Testable hypothesis. I love that one. Testable hypothesis. We talked about predictions, so I'm not going to cover that again, but testable hypothesis. What is a hypothesis? A proposed explanation for a phenomenon. I thought that science, according to the establishment, was not about explanations. And now they're talking about testable hypothesis, that you're going to test an explanation. You're going to try to verify the explanation to see if it's correct. And just in case, we have, this gentleman, he's a professor in Pennsylvania, and he says the following. He says, science doesn't explain. Science describes. So we have a contradiction. We have all these runarounds. They're saying science goes out there and does testable hypothesis. What is a hypothesis? A tentative explanation. And this fellow, who is a professor of physics, he says, oh, by the way, science doesn't explain. They don't do hypothesis. What they do is describe, which is not a hypothesis. Okay, he goes, what sort of answers can science give? If you want some mystical, ultimate, or absolute answer, you won't get it from science. Philosophers of science point out that science doesn't answer why questions. Science only answers what? How questions, meaning mathematics. That's what they call science. Science doesn't explain, science describes. Science postulates models to describe how some part of nature behaves, then tests and refines that model till it works as well as we can measure. Meaning they're going to do technology, and they're going to talk about this as being science. Okay, so they're equating essentially science with technology. They're saying that science is not about explanations. Science is about descriptions, mathematical descriptions. So why does everybody go to a scientist? Why does everybody go to a physicist, so-called physicist, mathematical physicist? Why do they go to Sean Carroll? Why do they go to Neil Tyson? Why do they go to Brian Greene? Why do they go to all these people asking them why questions, explanations, if they say it's not part of their, job description? They don't do why questions. They don't do explanation. And in fact, they try to do that. They give you the most irrational answer they can give you. When you question that, they say, by the way, that's philosophy. That's semantics. We don't do that. So why do we ask them? Why are we asking these people questions that they cannot answer, that is not part of their job description, part of their line of work? If they're into math, stay within math. Don't come into physics, which is what we're talking about. If this pen falls, we want to answer why, what caused this to fall, then hopefully we ask someone, a physicist, not a philosopher. And they say, well, this is philosophy. So is this philosophy? Is the falling of a pen, is the magnetism between two magnets there, is that philosophy? That's not part of physics? And if it is part of physics, these people can't answer the question. They tell, well, that's not part of physics anyways. It's philosophy. So we keep going around in circles and circles, and nobody ever addresses these issues. I mean, if they do testable hypotheses, and hypotheses are are tentative explanations. And then this professor and just about everyone else says that, they don't do explanation, they do just description. Why are we asking these people these questions? Why are they brought in talk shows and say, tell us about physics? And people ask them a question, they say, well, it's, because it branches out in several universes, and you could be in this universe and another universe over there. And you say, well, that's irrational. Yeah, it's all philosophy. So we keep going around and around in circles. Okay, so what is a description? What is an explanation for the purposes of science and purposes of physics? Here we have it. Description, a listing of properties of a physical object. That's all a description is. Okay, you have some synonyms. In science, we use adjective to describe objects. Okay, so description is just full of adjectives. We use the word narration, narrative, right? Typically a chronological listing of events. Okay, that's the how of mathematics, and what they do is quantify it, right? It's a story, it's an outline, chronicle. That's what it is. Okay? In science, we use adverbs to qualify or characterize motion. That's what mathematics is, just an exclusive language of quantitative adverbs. That's all that mathematics does. That's all an equation is. That's all that all these numbers and variables mean. It's just quantitative adverbs, how something moves. Okay? Math only describes and therefore is not a scientific language, because what science is? Rational explanations, not descriptions. A narrative is an uncolored, unopinionated story, objective reporting. And what is an explanation? Well, it's something totally different. It's the causes. Okay, the causes for the purposes of physics, reasons in the case of philosophy, right? Underlying a phenomenon, the prosecutor's version of how or why a consummated event happened. And the how has to be in terms of what caused it. That's what the how means there, okay? So explanation is the why, the theory. That's what an explanation is. It's got to do with causes. You have to theorize what caused something to happen, okay? And so you can see they're different than narration, which is what mathematicians do, which is just a chronological listing of events, typically chronological. And all they're doing is quantifying it with adverbs and saying this is how something moved. This is how it happened, not why it happened. And so it's not strange what I showed you the other day, that good old Neil Tyson, he wasn't able to explain gravity. And here it is again to his words. He more or less puts it all in the right perspective of what we talked about today. Here it is. Let me show you. Here it goes.
Science can describe how gravity works, but can they describe why it works? So this is the how-why duality here. In science, if we can describe how something works and predict its future behavior, we claim to understand it and we move on. There's a point where it's not especially productive to continue to think about the world that way. When you understand the how enough, are tantamount to having answered the why question. I can describe what gravity is doing. I even have a mechanism for it. Gravity really is the curvature of space and time. Movement of matter on that fabric of space and time we call gravity. Why does matter and energy curve the fabric of space and time? And I don't have an answer for that. Why does matter and energy curve space and time? Okay, that's a frontier. We're still working on that.
So why do we ask people like Neil Tyson, which has no answers to why questions, to explanations, and he believes that an explanation is a bunch of descriptions, and like he says, as long as they understand the description, they can measure and they can create some gadget, technology, they move on. And so they have this totally misconceived universe of how it works. They ended up with black holes, dark matter, all these spirits out there. They're conveniently invisible, conveniently heavy, with which they explain everything. And the question is whether there are such invisible, spirits out there, such as black holes and dark matter, dark energy, singularities, and whether Big Bang ever happened. So they have all these virtual particles, which are particles which they put in by hand, into their equation. They need that because otherwise the equation won't work. And so they say, well, it's a virtual particle. It just comes in and out so fast we can't measure it. Just, the angel came, did his job, and left in a split second. We weren't able to measure him. And so they have all these things today where are not things. They're invisible spirits that enter the world of math. They do a lot of math. They do a lot of research on them, and there's nothing to show for them. They cannot show you dark matter. They cannot show you dark energy. They cannot show you black holes because they are invisible. And then anyway, illustrate it. They illustrate a black hole and they say, okay, I understand what that is. That hole there with all this lightning around it, this halo around it. No, that's not a black hole. Black hole is zero deep, zero dimensional. That's what a singularity is. So, and then even if we concede all their assumption, how does it affect a star far away? And again, that's done through witchcraft. It's called action at a distance, through mass, through gravity, whatever. And they say, well, it's through space-time, all these, gravitational waves. What's a gravitational wave? It's the undulation of number lines, because what they're talking about is math, not physics. They're talking about the fact that they have these number lines, and they say, well, over here, the number line has such and such value, and over here it has another value. So they're talking about bending number lines. They call that physics. And, when you question that, they say, well, that's philosophy. They're only looking at numbers. Okay, so I'd like to end it with what I posted as the icon there for this, the Mary Poppins syndrome. That's what we have in math. You have Mr. Banks, the banker. He says, would you be so kind to explain all this? He asks that question to Mary Poppins. She says, let me make one thing absolutely clear. He says, yes, I never explain anything. That's the mathematician answer. Okay, they never explain anything. Okay, so math cannot explain, and here you have all the things that they cannot explain, everywhere from light, gravity, electricity, all the way to virtual particles and the twin paradigm. They cannot explain. They just describe, say, it is so. We measured it, and it is so. That's their interpretation. It doesn't mean that they can explain what they just said. Okay, and this is the problem that we have today. These people are at a crisis, and I'll be talking about that in the coming weeks. Okay. Mathematical physics is at a crisis. They're at a crisis because they're inventing ever more concepts on top of concepts on top of concepts. Mathematical concepts, quantitative concepts. And they just give names to these new concepts. They're developing equations that are totally unnecessary to understand the universe. The equations on black holes related to holography, and they've got all kinds of nonsense out there. And the question is, what do we need all that mathematics for? I just need to find out what causes this pen to fall to the floor. They cannot answer the simple question. And so they're developing unnecessary mathematics. They're bringing it into physics, calling it physics. And the questions that people ask are qualitative questions. They give you an irrational answer. When you put them against the ropes and question them about it, they say, that's philosophy anyways. That's not what we do. So why did we ask them those questions? And it goes on and on and on in circles. We'll see you next week.